Alright guys. So what have we done so far? We talked about radicals in general. Right? That's what we call root notation, square roots, cube roots. We just call them radicals. Then we talked about how radicals can be written as fractional powers. The minute we talk about that, we got to remember how powers in general work. Because now we're going to have fractions in place of these things. So, for example, how would you do this first little dude? What's that?
2 plus 7.
Yes, 2 plus 7. X to the 9. I like it. Not 14, right? That's magic. I got 2 x's there, 7 x's there. I got 9 x's all together. I can't magic 14 of them from somewhere. This one, beautiful. Because I had 7 x's in a row. 2 of them cancel. So I have 5 left. I like it. So add when you multiply. Divide, you subtract. Right? And then finally here, I've got 7 groups of 2 x's. So now I have how many? 14. I like it. You multiply when you raise them. I like it. I had someone a while back, they were like, when you multiply, you add. And they had something else, I can't remember, it's a long time. When you multiply things with like bases, you add the powers. Like multiply them. So, none of that cares what's in the power. In fact, there was a bonus question a while back where I said something, it was related to this, it was a lot harder than this, but x to the b times x to the 3b minus 1. Now some people are going to look at that and say, holy shit, man, there's enough variables, are you throwing them in the... But math doesn't care. We care a little bit, but the process says when you multiply like bases, you add the powers. So it's x to the 4b minus 1. I like it. That was no more difficult than that. Just had to add your like terms. So now, specifically, if I have x to the 1/3 times x to the 2/5, math doesn't care. It still says add the powers. We care a little bit because if the powers are just whole numbers, it's easy. If the powers are fractions, I have to add them correctly, which means I have to get like denominator. I like it. Good. So this will be 15 times 5 plus 3, 5 plus 6, 11 15ths. Cool. I like it. So the properties of exponents don't care what the exponents look like. We care a little bit because we got to know, do we need LCD? What do we need to add like terms? But the basic idea, add them, doesn't change. I like it. And what about this here? What do you got, Jeff? Sure. I like it. Yeah, so now this is a situation where you multiply the powers. But of course, in the process of multiplying, you should do what? This is y to the 5/3. Cool. Some of you guys look at me. Is that it? Yeah, so that's basically it. I mean, just got to get like denominators if you have to add or subtract fractions. You don't need LCD when you multiply. Of course you don't, because the whole idea there is to cut things down, not build them up. Thank you. Okay. So there's a whole little section like that. Nothing's new. It's the same old properties of exponents. So what about this? This is kind of leading into the next section. Let me see what you guys think about this. There's 4 there.
I think the multiply the x victory. It's multiply the down one, this one, the x 3.
Multiply, how do you mean? Oh, I see what you're doing. It's not this yet. Do these have the same base? Yes. They're both based on x, aren't they? They're just not written in the better way so I can see what the hell's going on. Now, real quick little side note. This is what the next section is going to deal with. If I had the 5th root of x to the 4th divided by the 5th root of x, I can actually divide those because the roots are the same. I can make it one big ass 5th root of x to the 4th over x. And then I can just reduce that and make it 5th root of x cubed. Now why can't I do that here?
Because the roots aren't the same.
The roots are not the same. Stupid roots. That doesn't mean the band. Band's fine.
It's not multiply the down one, both of them.
No. You're thinking about rationalization. I don't have to do that yet because I can simplify this much better in a much easier way. How do I rewrite them as fractional powers?
6 to the 5 4.
Roots on the bottom.
X to the 1/3.
Good. And now that looks sort of like this, or like that. I just need to get LCD, and then I can do what with them?
Subtraction.
Subtracting, because it's division. I like it. Now this is kind of cool. I really want you guys to realize what's happening here. Why could we not do this? The roots were not the same. Where are the roots in a fractional power? Where are they? On the bottom. So when I make LCD, I'm changing the bottom to be the same number, and the bottom is the root. I'm making them have the same root when I make the LCD. If you don't quite get what I'm saying, it's okay. But that's the way around. If the roots are not the same, I make it look like a fraction, so then I can make them have the same denominator, which is making them have the same root. If you don't quite get what I'm saying, it's okay. It's not necessary. So what's the root going to be, of course? I mean, the LCD? 15 again, so now I multiply by. So it would be 12 fifteenths minus 5 fifteenths x to the 7 fifteenths. Everything started off as radicals, so your answer should end up as a radical. What's up? Is everybody all right? All right, 12 fifteenths, 5 fifteenths, 7 fifteenths. So this would be the what root? 15th root, x to the 7th power. I like it. It's kind of neat. So if it's written in radical form and you're trying to do stuff like you got to rewrite it as fractional form, because then you can actually attack it.
And then the answer has to be rewritten.
Yeah, whatever form it started with is the form we should take in the end.
Okay.
And some of the problems say to leave it in a certain form, but if they don't, say bring it back to whatever form it started off in. A sort of convention. The guy, if you stop there, the guy's like, I had roots. Oh, all right, weirdo. There's a root for it. It's just convention. All right. I just made fun of all my people. All my math people. Okay, cool. I like it. I think that was the last little bit from there. Yes. I like it. So one little thing that hopefully you guys realize is kind of silly. If I said simplify this, I kind of gave it away a little bit, but is there really anything you can do? You can make an LCD all day long, but why can't you do anything past that? Because the bases are not the same. Shit. All right, maybe. So there are a couple problems. It says rewrite fractional powers and then simplify if you can. Well, here all I could do is x to the 2/7 times y to the, and then I stop because the bases are not the same. So the rules don't work here. The bases have to be the same for me to do all that power stuff. Okay. So that's section 10.2. 10.2 is all about why does it make sense that radicals can be written as fractional powers. And then the minute that we do that, we got to remember, oh shit, now all my old properties are the same, but I got fractions inside of them. Shit. So you got to be careful about that. All right. There's a lot of shit in section 10.2. Just got to be careful. All right. Now, I want to do a little bit out of this next section, and I'm going to let you guys attack a little group work handout thing. I know, I've been talking a lot. Actually, let me do this. I haven't talked a lot. Let me shut up. I'm just going to have you guys work on some of these right now. Actually, do everything you can on the less interesting side. The other side has got a little more. That's the side that relates to section 12.3. We haven't talked about 12.3 yet. So work on this side together or alone. It's up to you. Oh yeah, I meant to put it there earlier, but